My name is Ian Nettleshire. I'm an associate professor in the Department of Mechanical Engineering and Material Science at the University of Pittsburgh, and I lead the ceramic water filter project. When people look at a cell phone like this, they see a device, but actually we see a material system. It's made up of many different materials, and the substructure of these materials has been manipulated and controlled. And what we're interested in the ceramic water filter project is how we can do the same thing for technologies that have been developed for low-income communities around the world that suffer from extreme poverty. Most low-income communities do not have large-scale water treatment facilities. As a consequence of that, the drinking water is often contaminated by bacteria and other pathogens.
The way that the ceramic filter works is it's actually a quite ingenious design that was put together by ordinary potters and ceramic artists. They take an ordinary potting clay and mix in sawdust, and then they fire it. When it fires, that sawdust burns out and it leaves small holes, pores in the microstructure. We had to go there to see it to understand how the system really worked.
We were working with trying to increase the strength because the filter as it currently stands is rather friable. It's easy to break, which is one of the big concerns in terms of individual use. A lot of folks, if they purchase one of these filters, it's cheap to us, only a few dollars, but to them, those few dollars, that filter needs to last them 2 to 5 years. And if it gets dropped or it gets broken, then they're out a lot of money.
So what we're interested in is looking at technologies that address their basic needs. They need to be able to clean their drinking water. They need to be able to grow or trade for nutritious food, and they need shelter and things like that.
What we're going to do is a little demonstration. Just going to take some normal water, add a little bit of dirt, some mud. So this is how your water might look, and I've seen pictures of children drinking from bottled water, and it looks about this color, but this filter can actually remove about 99% of the particulate matter, and more importantly, about 99.9% of the bacteria. So we'll just pour it in the top. So the typical flow rate of this filter is 1 to 3 liters per hour. It's not a lot. That's one of the things that we're aiming to improve. If we can improve the flow rate, as we are trying to do, then we could, for example, with one filter provide enough water for an entire family at the rate of water that they actually need.
On the ceramic filter project, we are really very focused on one technology, and to develop one technology requires all kinds of different engineers, and they all bring us a very welcome perspective to this problem. We want to train our engineers to be able to work under these very special and quite severe constraints. How you manufacture things in low-income communities with very little resources and education.